In the late summer of 2025, a message began circulating quietly through the networks of radio astronomers and spaceflight enthusiasts. Voyager 2, the spacecraft launched nearly half a century ago, had reported something unusual. It was not the first time Voyager 2 had sent back strange data. In July of 2023, it briefly lost contact after an antenna misalignment, only to reconnect later. The new report, however, was different. It did not involve a mistake or a glitch. It involved a signal, and then a second signal. Voyager 2 drifts more than 20 billion kilometers from Earth, far beyond the orbit of Pluto, deep into interstellar space. It carries instruments that still function, though many have been shut down to save power. Its transmitter whispers faintly across the void, a stream of radio pulses so weak that giant dishes on Earth must strain to hear them. For years, that whisper has been steady and predictable. But in September of 2025, the whisper changed. Operators at the Deep Space Network first noticed a faint sideband in the Voyager 2 carrier. A narrow line of static appeared where none had been before. At first, it looked like interference, perhaps a reflection in Earth's ionosphere or a fault in the receiver electronics. Engineers checked with other dishes. The Canberra station saw it. Madrid saw it. Goldstone saw it. The anomaly was real, and it was coming from the direction of Voyager 2. The first signal persisted for several hours. Then it vanished. Analysts tagged it as unexplained but inconclusive. A week later, it happened again. This time the sideband carried faint modulation, a pattern riding on the carrier. Not voice, not data packets, but a sequence of pulses spaced in intervals that suggested order rather than noise. When operators demodulated the signal, they saw repeating groups of 3, 5, and 7 prime numbers. The discovery sparked urgent debate inside NASA's Jet Propulsion Laboratory. Voyager's instruments were not transmitting primes, its engineering data used fixed binary formats. Its science data came in packets defined decades ago. Nothing in its design could produce clean sequences of prime intervals. Some suspected a reflection or echo, perhaps Earth signals bouncing off an object in deep space. But the geometry made that unlikely. The timing matched Voyager's line of sight. The pulses arrived at exactly the same delay as Voyager's own carrier, only offset by a narrow band of frequency. For days, teams combed through logs. They compared solar activity, ionospheric conditions, and even satellite interference. Nothing lined up. Then, in early October, the anomaly returned. The second signal emerged again, stronger than before, lasting nearly 12 hours. Amateur radio astronomers monitoring the downlink with smaller dishes confirmed it. The pattern repeated. Prime intervals, clean and sharp, not random noise. Voyager 2 had picked up a second mysterious signal. The fact that it was a second signal mattered. One anomaly could be dismissed as interference. 2, spaced apart, repeating the same pattern, forced attention. Astronomers struggled with the implications. Voyager 2's antenna is not a receiver in the normal sense. It transmits data to Earth, and it can pick up commands from Earth. Its receiver listens only to tightly defined frequencies reserved for mission control. The new signal did not match those. It came from a nearby frequency, as if injected alongside Voyager's own carrier. One possibility was that the signal originated from Voyager itself, a product of aging hardware. The spacecraft's radio system, designed in the 1970s, has survived cosmic rays, temperature swings, and the slow decay of power. Perhaps a transistor was oscillating, creating spurious sidebands, but engineers rejected that idea. Hardware noise does not arrange itself into prime number sequences. Noise does not switch on and off for hours at a time. Another possibility was that something in deep space was re-radiating Voyager's signal. If an object passed near the spacecraft, it could scatter the radio waves back toward Earth, shifted in frequency. That idea gained traction when analysts calculated the energy of the sideband. It was too strong for random noise, yet too weak to be a deliberate transmission at Voyager's range, unless the source was close to the spacecraft. The geometry suggested an origin within a few thousand kilometers of Voyager, at interstellar distances that meant the signal was practically on top of it. The image of Voyager 2 drifting alone in the dark, accompanied by a faint source of signals, stirred the imagination. 48 years after launch, the spacecraft may not be alone. Astronomers ran scenarios. If a natural object, such as a dust cloud or plasma sheet, was interacting with Voyager's transmission, could it create sidebands? Plasma can scatter and modulate radio waves, but not into neat prime intervals. If a natural body like a comet fragment passed near Voyager, could it reflect signals? Perhaps, but no known body drifts in interstellar space that close to Voyager. Its trajectory lies far outside the Kuiper belt. The likelihood of a chance encounter was tiny, as speculation mounted. Researchers remembered the earlier interstellar visitors, Oumuamua in 2017, Borisov in 2019, and then 3I Phaeatlas and Swan in 2025. All challenged expectations. Now Voyager 2, humanity's farthest probe, was detecting anomalies in its own communication line. Some suggested the events were connected, pieces of a larger puzzle. Inside JPL, teams set up round-the-clock monitoring. Each time Voyager's carrier reached Earth, they searched for the second signal. Sometimes it was absent. Sometimes it flickered faintly. Other times it blazed into clear prime sequences. The randomness of appearance suggested it was not tied to Earth conditions. The modulation strength suggested proximity to Voyager. Analysts began to treat the sideband as if it were a companion transmission. Amateurs joined in. In Europe, hobbyists with 1-meter dishes tuned into Voyager's band. They confirmed the anomaly on nights when it was strongest. Some even claimed to detect additional patterns beyond primes, though their equipment lacked the sensitivity to prove it. The collective effort created a map of sightings. Wherever the anomaly was confirmed, the data pointed to the same source. Near Voyager 2, scenarios multiplied. One argued that the signal came from a previously unknown natural phenomenon in interstellar space, perhaps a plasma structure interacting with Voyager's carrier wave. Another argued it was a deliberate beacon using Voyager as a relay. If an external craft or probe sat near Voyager, it could inject its own signal into Voyager's stream, letting Earth receive it without needing separate detection. That concept echoed science fiction, but it matched the data. The sideband rode on Voyager's carrier like a rider on a horse. Some asked why Voyager 2 and not Voyager 1, the other spacecraft farther out. Voyager 1 still transmits, though its instruments are weaker. It had not reported sidebands. Perhaps Voyager 2's trajectory intersected a structure or object Voyager 1 had missed. Perhaps the anomaly was local, a companion that had chosen Voyager 2. The second signal carried no obvious message. The prime suggested intent, a way to flag intelligence. But beyond that, no content was clear. Analysts tried Fourier transforms, autocorrelations, and time-frequency analysis. They looked for embedded data. Nothing conclusive emerged. The modulation could be a beacon, a handshake, or a test. The lack of complexity kept speculation alive. If it was a signal meant for us, why so simple? If it was not meant for us, then what purpose did it serve? Some researchers warned against rushing to conclusions. They remembered the "wow" signal of 1977, a strong narrowband pulse never repeated. They remembered false alarms from satellites and terrestrial interference. The prudent path, they said, was patience. Collect more data, rule out Earth sources, rule out hardware faults. Only then consider extraordinary explanations. But patience did not slow the chatter outside official circles. Podcasts lit up, forums debated whether the signal came from probes, whether Voyager had been intercepted, whether this was the long-expected response to human radio transmissions. The story spread quickly because it tapped into a powerful image, our oldest explorer drifting in the dark, whispering back that something else was out there. Scenarios reached further. If the second signal was external, perhaps it came from the same forces shaping Atlas and Swan. If interstellar probes existed, Voyager might have stumbled across one. The idea carried irony, a human probe built in the 1970s. wandering so far that it met another probe not of human origin. The coincidence would be staggering, yet the possibility was entertained because the data did not vanish. The second signal remained, repeating often enough to resist dismissal. Engineers considered the risks. If Voyager was near another source, could commands be interfered with? Voyager still receives occasional updates from Earth. Its antenna listens for coded instructions. If another source sat nearby, could it jam or spoof? The thought was unsettling. Voyager is old, its systems fragile. A false command could disable it. To guard against that, controllers tightened their command schedules. They limited uplinks. The silence deepened. Meanwhile, the data archive filled with hours of sidebands. Analysts began to notice subtle variations. The pulse groups sometimes shifted, from primes to Fibonacci intervals. Sometimes the spacing stretched or compressed, as if adjusting the changes hinted at experimentation. If it was noise, it should remain random. If it was a glitch, it should repeat identically. The variability looked deliberate. To illustrate the scale, consider how faint Voyager's signal is. By the time it reaches Earth, the power is less than a trillionth of a watt. Yet even at that level, the sideband appeared. To inject a companion signal, a source near Voyager would not need enormous power. It would only need proximity. A small transmitter could ride alongside Voyager and beam back with it. Earth would pick up both. The distances involved are almost incomprehensible. Voyager 2 lies nearly 20 billion kilometers away. Light itself takes more than 18 hours to cross that gap. Commands sent today arrive tomorrow. A signal detected now left yesterday. The second signal therefore represents a source operating with us on interstellar timescales. Not seconds, not minutes, but days. To coordinate with Voyager's carrier, the source must sit within that immense darkness far beyond any planet or known object. Astronomers tested the idea of natural companions. Could Voyager have drifted near a rogue planet, a dark body wandering the galaxy? None showed up in infrared surveys. Could it have passed a cloud of plasma tied to the galactic magnetic field? Possibly, but again, no known structure sat where Voyager was. The interstellar medium is thin, almost empty. The odds of stumbling into a plasma feature able to modulate radio waves into primes were nearly zero. The mystery deepened when, in late October, Voyager 2's downlink carried the sideband for nearly 2 full days. It was the longest continuous episode, yet analysts compared notes across continents. The prime sequences repeated steadily for hours, then switched to a new pattern, then returned. The pattern looked like testing, as if the source were probing the limits of Earth's ability to hear. At JPL, some researchers suggested responding. If the source was near Voyager, Earth could transmit a strong coded signal aimed at it, asking for a reply. But such an experiment carried risks. Broadcasting openly might attract attention of unknown kind. Others argued it was pointless. The round-trip time of nearly 36 hours would make interaction painfully slow. The debate went unresolved. Officially, no response was sent. Unofficially, some suspected small test signals may have been transmitted, but no record was shared. The story reached the public in fragments. Press releases downplayed it as unusual noise. Independent astronomers spoke more freely, describing the sideband and its strange modulation. The phrase second signal took hold. The mystery had a name, and with it, a grip on imagination. Voyager 2 continues to drift outward past 132 astronomical units into the endless dark. Its radio still whispers back. Alongside that whisper, faint companions appear, intervals that do not belong to noise. Whether they represent a natural quirk of interstellar plasma, a malfunctioning component, or a beacon from something else, the second signal stands as one of the most intriguing anomalies in decades of deep space communication. For now, the record grows each day. Hours of sidebands, groups of primes, shifts in intervals. Astronomers remain cautious, baffled but careful. The second signal is not dismissed, but it is not yet explained. Voyager 2, launched in 1977, still writes new chapters nearly half a century later, carrying not just the memory of human exploration, but perhaps also the faint signs that in the deep beyond, we are not the only ones transmitting.